question of today, and so we can rephrase it this way. Sine of x is equal to the ratio of opposite to hypotenuse is 1 to 2. The ratio is known. So remember, how many times have we talked about this? It's all about knowing the ratios. Once you know the ratios, for example, all you got to do is know one side of the triangle and you get the other two. Now I'm adding even more stuff to that. There's even more. We should make an infomercial for ratios. But wait, there's more. If you know the ratios, you can also find the angles. And the way we do this is we use an inverse function idea. The idea is that here's an abstract look at the trig functions. Their domain is ratios, okay, or their domain is angles, all sorts of angles. And the trig functions, for example, sine or cosine or tangent or all the other ones, what they do is they give you ratios. Okay? So you put angles, for example, 30 degrees, and you go through the sine, for example, let's scratch these out of the way, sine, and that would give you 1/2. The ratio is 1 to 2. What the inverse functions do, first of all, sometimes they're written like this, sine with a little -1. They take you back the other way. Their domain is the ratios, and their codomain is the angles. In other words, if you tell it the ratio, it will tell you the angle. They go backwards, of course, but there's some issues with this, and maybe it's best that we talk about them now. Okay? Here's the issue. If you go negative 330 degrees, for example, and you go through the sine function, it also gives you 1/2. Why? Because I'm thinking here, 30 degrees, the reference triangle is right here, and that's the same reference triangle for negative 330 degrees. So the ratio, of course, is going to be the same, 1 to 2. In other words, the fancy way of saying this is that this function is not 1 to 1. Okay? And when it's not 1 to 1, how are you going to go back? If I pose this question here, the opposite is 1 and the hypotenuse is 2, what's the angle? Technically speaking, you might say, well, it's 30 degrees, but then in some sense it could also be, there are more than one choices for x. X could be 30 degrees, or x could be 330 degrees, negative 330 degrees, or x could be a bunch of other things, 390 degrees, etc., etc. There are many possible values for x. And this is actually a discussion that we will leave when we actually have a section called Solving Trig Equations. For now, suppose we just restrict ourselves to just first quadrant stuff, just angles from, not consider all the angles in the world, but just consider some of the angles. In fact, this is how it's traditionally done. Suppose you restrict the domain and say, you know what, we're not going to accept any old angle. No. We will only accept, for example, for sine, we will only accept angles in the domain that are between 90, theta between 90 degrees and negative 90 degrees. That's it. Nobody else is allowed to be in this domain for the sine function. This is called a restriction of the domain. If that happens, then you could take the ratios, and when you go back, sure enough, you don't have many choices. You only have one choice, meaning that whenever there's a viable ratio here from -1, by the way, the only viable ratios here are between -1 and 1, since the sine function could never be more than 1 or less than -1. Since it's the ratio of opposite to hypotenuse, the opposite cannot be larger than the hypotenuse on a Euclidean triangle. Whew, that was a lot. Let me take a breather here. So, we restrict the domain here, angles between negative 90 and 90, and then there's no problem. And so we summarize this way. For sine functions, for sine, okay, think about its domain here, its bucket of things that go into it. We will only consider angles that are between negative 90 degrees and positive 90 degrees. And its codomain will be ratios that are between -1 and 1. Maybe we use this interval notation. This way, the sine inverse function has no problems choosing the right angle. And so, for example, if you go to 30 degrees, you take the ratio, it's 1/2. You take the sine inverse function, and it, of course, is 30. That gives you an opportunity to also point out the different notations for this. Some people call it arc sine function. And also it gives me the opportunity to point out that you should get familiar with your calculator. This ratio we knew because it was famous. We knew that sine of 30 is 1/2, so the inverse is 30 degrees. However, there may be times when you don't have a famous one, so you should really, again, get to know your calculator. Or let me see if I can pull out this software calculator that we have on board here, our little friend, the magic number machine. Here, you should practice this. Inverse sine. So I think you got to do, first of all, let's clear everything. You got to do shift sine. That puts the sine inverse function on there. And then you do, I'm going to open up a parenthesis here. Go 1/2 and then close the parentheses just to make sure I get the right one. Then hit enter, 30 degrees. I told you. Didn't I tell you? That's why they pay me. By the way, the mode is degrees. If I had radians, it would give me the number of radians. Okay? Make sure you practice using this. Here, let's do one that's not famous. Let's do one that is not famous. So let's change it up a little bit. So anyway, so here the 30 degrees is the one we go with. So what would happen if we change it up to something that's not famous? Say we have a triangle here where the ratio is 3 to 10. We'll take that 3 to 10, and you want to know what is this angle theta. By the way, sometimes angles are called variables are called theta, or sometimes they're called x. Either one is just a variable. Theta. All right, we'll make sure it's a right triangle, and in this case we know. Well, let's turn it down a bit. Sine of theta is equal to 3/10. The ratios are known. That should be enough for you to find the angle. So here, two things. One of the things is there are many angles that fit this, and later on we will learn how to solve all of them. The calculator will give you the angle that's between 90 and -90 degrees. So we go to our fancy little calculator here, our magic number machine, and I go like this. I go clear this. I go shift sine. That gives me the arc sine function, or the inverse sine function. And I'll open up a parentheses and I'll go 3 divided by 10. And I'll close the parentheses. And, whoa, 17 degrees approximately. So therefore theta is approximately 17 degrees. See how easy that is? Of course, that's not the whole story, you know. We're using the calculator for something that we really don't know how to do. So I don't know how that makes you guys feel, but it doesn't make me feel good, but that's all we got for now until you learn calculus. Alright, anyways, that's the sine inverse function, and similarly the other functions have some restrictions too. Cosine, for example, the cosine function, it can usually take any sort of angle here. If we restrict it to angles that are between 0 and 180 degrees, it will have, and the codomain is -1 to 1. This is the cosine function. So the cosine inverse function will work nicely here, where you only have one choice to go back to. Okay, this is the way your calculators most calculators are programmed. They're programmed to give you, out of all the millions and millions of possible angles that give you the same ratio, they program to give you the angle that fits right between 0 and 180 degrees. Want to try some? Let's try it. Talk is cheap. Let's go with this one. What if we replace, let's go with another one. Oh, can you guys do it backwards? Take that. So what if you know the what if you're standing here now from this point of view, and this is theta, and suppose the angle right next to you is, or sorry, the side next to you is 7 and the other one is 8. Whoa, you know the ratios now. The question is, how would you figure out theta? You'd say, hey, this is the adjacent and this is the adjacent to here, adjacent and hypotenuse. Which function tells you the ratio of adjacent to hypotenuse? Cosine function does. So you'd write cosine of theta is equal to 7 over 8. And you think to yourself, well, there are many solutions, and we'll learn all those in the next few chapters, but for now, I can find one of the solutions, the one that's given by the calculator, the one that's between 0 and 180 degrees for cosine. So theta would be approximately, again, you would use a little magic number machine, and I'll play this game. Clear everything. I don't know if you guys can see, clear everything. Then I'm going to do a little shift cosine, that's the cosine inverse function. Then I'm going to do 7 divided by 8, then I'm going to close the parentheses, then I'm going to hit equals, and it gives me approximately 29 degrees. See that? I told you. By the way, now it would be easy to find the other one. The other one would be, it's complementary, so if this is 90, this one over here has got to be about 61 degrees. So that they make up 90. Easy, huh? I'm going to try another one. Let's try another one. What if you have, I'm going to freehand it here. What if you have theta here, and what if this side over here is 7 and this one is 5? Well, which sides are being given? The opposite and the hypotenuse. So sine is the one I want. Sine would be opposite over hypotenuse. Then I try my little sine function, my number machine here. Magic number machine. Clear everything. Shift sine, open parentheses, 7 divided by 5 is equal to what? What in the world is that? OMG. This number machine is good. I was going to surprise you guys, and it surprised me. Anyways, it's giving you the non-real number. It's actually a complex number, which is way beyond the scope of this class. Hopefully, when you try it on yours, it'll give you error to tell you that something's going on here. Let me see. Maybe we should erase that. All right. So if you try to put it into your computer, your calculator, this will tell you not a real number, and you're thinking, what? Not a real number? How'd you get that? Or some of your calculators may say error, and say, what? How's it giving you error? Well, here's the deal. On a real triangle, Euclidean triangle, the opposite guy is 7, hypotenuse is 5. That's not real. That can't happen in real geometry. We agree that on real triangles, big angles make big sides, so bigger angles make bigger sides. 90 is the biggest angle, so this side has to be the biggest. The hypotenuse has to be bigger than the 7. You see what I mean? Otherwise, this is not a real triangle. And if your calculator is a regular run-of-the-mill calculator, it'll tell you error. If it's a fancy one like the one we got here, it'll give you a non-real solution, a complex solution. Very fancy stuff. Anyways, get to know your calculator. Practice a lot using these inverse functions. You should be good at the sine, the cosine, and before we go, let me tell you about the tangent. The tangent restriction will go like this. It'll take angles that are from negative 90 degrees to positive 90 degrees. It'll give you ratios. Ratios go from negative infinity to positive infinity. This guy could take any ratios because it's the adjacent and opposite and adjacent, so they could be as large as you want. There's no restriction there. So the arc tangent function, or the inverse function, will send you back to this range right here, 90 to negative 90. That's what the calculator will usually give you. Okay, and the rest of the story will come later on when we solve equations like this. Tangent of x is equal to 3 over 4, for example. It's a long story behind that, but we're just not ready for the entire story. For now, we just restrict ourselves to solving angles or here in a right triangle. You can almost think about it as just sticking to the first quadrant area. Okay, practice using your calculators. See you guys here next time. Peace.